Students, this is Mr. Ezra. In our last video, we talked about how to complete the square in situations where completing the square to solve a quadratic was a fairly easy thing to do. Today, we're going to level up and look at some problems that are a little bit more difficult. We'll start with a question where the leading coefficient is not 1. This is generally a pre-requirement for completing the square. And since 2 is in front of x squared, this isn't a situation where we would automatically think I should complete the square, because it requires you to have a 1 in front. But we can use a property of algebra, which is called the division property of equality. And the division property of equality basically says if you divide everything on each side of the equal sign by the same thing, you keep the equality. It doesn't change, it stays equal. So I'm going to divide everything on both sides by 2. So that this 2 here and this 2 down here essentially cancel out, leaving me with just x squared. 8 divided by 2 is 4x. And minus 15 over 2, I probably could write it as a decimal, but I'm going to leave it as the fraction 15 over 2. 0 divided by anything is still 0. So now I have a situation where the leading coefficient is 1, and I can go ahead and complete this square. Excuse me. I can go ahead and complete the square with the same steps that we used in our last video, which is first to essentially put your x's, x squared plus 4x on one side, leave yourself a space there, so plus something, and add or subtract this constant to the other side. So since it's minus 15 over 2, I'm going to add it to the other side, and I'll have plus a space over here. Now I've got to figure out what goes in this space, so I kind of come off to the side, and remember what goes in the space is b over 2 squared. In this case, that's 4 over 2 squared. Well, 4 divided by 2 is 2, and 2 squared is 4. So I'm essentially going to be adding 4 on both sides of the equal sign. Well, on the right side, I'm not really going to add this together. In fact, I can't, but instead now I have something that is factorable, and it's a special type of factor called the sum or difference of two perfect squares, and you get that by putting x plus whatever you got for b over 2. So that would be 4 over 2, which is 2, so it'd be x plus 2. And the easy way to get there is to say half of 4 is 2. So that takes care of my left side. The x squared plus 4x plus 4 is now x plus 2 squared. On the right side, I've got a little bit of fraction work to think about. 4 is an integer, and 15 over 2 is a rational number. We want to turn 4 into a number like 15 over 2. So instead of 4, I'm going to use something over 2. Well, what would be over 2? It would be 8. So now we have 8 over 2 instead of 15 over 2. So 15 plus 8 is, let's see, 23. And 2 in the denominator when you're adding fractions is going to stay the same. So 23 over 2. Now I'm going to take the square root of both sides, and when I do that, remember that you have to have positive or negative square root on the right. The left side, the square root cancels out with the square that's already on your binomial, which leaves you with x plus 2. On the right side, we have positive or negative square root of 23 over 2. I'm going to go ahead and take care of this denominator here. We don't like an answer with a radical in the denominator, and this is a square root of 2 in both the top and the bottom. So we got to get rid of the square root of 2 in the bottom. To do that, we're going to do something called rationalizing the denominator, which basically just means you multiply the top and the bottom by the square root of the bottom. Okay, so the square root of 2 times the square root of 2 is 2, because 2 times 2 is 4, and the square root of 4 is 2. 23 times 2 is 46, but that's still under the square root. And in fact, 46 is not a perfect square, and there's no perfect square less than 46 that goes into it other than 1. Nothing bigger than 1 that goes into it. So we're going to leave it as the square root of 46. So when we come down to our next step, I want you to remember that this number is added or subtracted across, right? It's just going to go right here. But it's positive, so to go across the equal sign, I have to subtract it. So I'm going to have a negative 2 plus or minus, and I'm going to use the simplified version of this, which is the square root of 46 over 2. And this is a final answer. Remember, there are two solutions here, negative 2 plus root 46 over 2, and negative 2 minus root 46 over 2. Second example today is a word problem. It's what ups the difficulty on this one, I suppose. So let's dig into this word problem. The first thing that it says is the length of a rectangle is 8 centimeters longer. I'm sorry, 8 centimeters greater than its width. The area of a rectangle is 170 centimeters. What are the approximate dimensions of a rectangle? I'm the kind of student that when I see a problem like this, I can't just jump in and start doing the math. I need to see the picture. So I'm going to come off to the side and I'm going to draw myself a rectangle. It doesn't have to be perfect, just needs to look like a rectangle. So I can kind of get an idea of what this picture is going to look like. I know that my width is less than my length. My length is 8 centimeters greater than my width. So if this is my length right here, it's got to be 8 centimeters longer than the width, which is right here. There's width, there's length. So if I let x be my width, you could use w, you could use any variable you want, but I'll use x. If I let x be my width, then length has to be 8 more than that. Okay. Now, how do you find the area of a rectangle? You multiply the length times the width. You multiply these two numbers together. Well, this time they're not numbers, they're algebraic expressions. So we're going to multiply them together. So I'll say that x times x plus 8, or x plus 8 times x, is equal to the area of this rectangle, and I happen to know the area of this rectangle. It's 170 centimeters squared. So some x centimeters squared times some x plus 8 centimeters, let me say that again, some x centimeters times some x plus 8 centimeters has to be equal to 170 centimeters squared. This is my area formula, right? Well, I'm going to go ahead and distribute the x into the x plus 8 to get x squared plus 8x. Now, this is a situation where completing the square is a good idea because we already have all the x's on the left. We're going to add some unknown thing to both sides, but we know how to find that unknown thing, right? We find it by b over 2 squared. So that unknown thing here is going to be 8 over 2 squared, which is 4 squared, which is 16. So I'm going to add 16 to both sides of the equal sign. Remember, on the left, all this gives us permission to do is this is why we call it completing the square, because we're forcing this to become a perfect square binomial. It's going to be x and then half of 8. Remember the 8 over 2 over here, it's half of that. So 8 over 2, or 8 divided by 2 is 4. It's going to be plus 4 in parentheses squared. The left side is always going to be x plus or minus some number, all in parentheses squared. And then on the right, we've got 170 plus 16, which is 186. Now, as is normal with completing the square, I'm going to take the square root of both sides of this equal sign. When I do this, the left side comes out as x plus 4. And the right side is going to be, remember, positive or negative square root of 186. Now, this is a word problem, and it doesn't say what are the exact dimensions. It says what are the approximate dimensions. So in the past, we've been very careful to keep things in radical form, but this word problem, by saying what are the approximate dimensions, has given us permission not to have to worry as much about this 186 under the square. We can just go ahead and change that to a decimal, okay? Another thing that we want to think about, can the length or width of a rectangle be negative? And the answer is no. And since we can't have a negative length or width on our rectangle, this plus or minus, which is technically there for the completing the square, in this problem, we're not going to use the minus because we're not going to have a negative length or a negative width. So it's unnecessary. So as we bring this across, remember we have to bring the 4 across by subtracting. So it's going to be negative 4 plus the square root of 186. We can actually just put this in our calculator. Negative 4 plus the square root of 186. And this is should give you 9.64 approximately. You're gonna have to round it, right? I'm gonna go 2 places past the decimal, 9.64. Now, a lot of students, when they find what x is, they've been so conditioned that they get out their pen or pencil and they circle that guy and they say, I got it, done. But this is a word problem, and we're not finding this one solution. We are finding the dimensions of this rectangle. Well, what we found is x, and x represents something, right? X represents the width of the rectangle. Okay, that's x, the width of the rectangle. Well, our width is going to be 9.64 approximately, right? It's not exact, but it's approximately. The length is the other dimension of this rectangle, and it's represented by x plus 8. And we can find the length of this rectangle by taking 9.64, the approximate length of this rectangle by taking 9.64 and adding 8. And that should give you about 17.64. That's the approximation. So these are the actual answers. These are the 2 dimensions that we're looking for, or something very close to them. Our third example is x squared minus 5x minus 1 equals 0. So let's take a look at this one. We're going to we know we have a leading coefficient of 1, so we're good to go ahead and begin the completing the square process. But what's going to happen here, you'll see in a minute, is first I'll go ahead and add the 1 across, because that's a negative 1, I'll add it across. And I know I'm adding or subtracting something, or actually I'm adding something to both sides. I've got to find what goes in that box. What is the missing thing that goes in this box? And we know to find that missing thing that goes in the box, we do b over 2 squared. In this case, that's box is going to be equal to negative 5 over 2 squared. Well, negative 5 times negative 5 is positive 25. And 2 times 2 is 4, so we get 25 over 4. And that is what we're going to add on both sides. 25 over 4. This trick on the left side of this equal sign allows us to change this to a perfect square binomial. Remember, we take b over 2 to go inside this parentheses here. Well, that's going to be minus 5 over 2. So we have a fraction. Don't be afraid of it. It's okay. You can do this. All right. So that's x minus 5 over 2 squared to complete the square there. On the right side, I have to add 1 plus 25 over 4. And remember, 1 can be represented as any number over itself. So to get like denominators, I'm just going to do 4 over 4 plus 25 over 4. You can always use your calculator and let it do the thinking for you, but you have good brains and you should be able to handle fractions. So when you add fractions, the denominators stay the same. 4 plus 29 in the numerator is going to be 29. So we get 29 over 4 on the right. Our next step is to take the square root of both sides. We take the square root of the left, take the square root of the right. On the left side, all that happens is the 2 goes away. We take the square root. We get x minus 5 over 2. Because the square root of a perfect square cancels out. They cancel each other out, right? On the right side, remember, you got to have a positive or negative root. Okay, so when we come down here, it's going to be equal to positive or negative. Now, when I do this, the whole thing is under the square root, right? 29 is not a perfect square, and it doesn't have a perfect square that divides evenly into it. So we're just going to leave it as the square root of 29. But 4, on the other hand, is a perfect square. The square root of 4 is 2. So I'll go ahead and take the square root of that. My last step is to add 5 over 2 to the right. So it's going to be positive 5 over 2 plus or minus root 29 over 2. And that is a perfectly good way to write that answer, is this fraction plus or minus this fraction. You might alternatively see it written with, since the denominators are the same, we can combine those and just say 5 plus or minus root 29 over 2. You can see that the steps are really the same here. We're not doing anything inherently different, but because of the fractions, it does require a little bit more thinking on your part, and you're remembering how to square a fraction, how to add fractions, how to take the square root of a fraction. All that stuff you got to be able to do to get the right answer. And for our final example today, we're going to look at one where we actually have no numbers. It's all letters, okay? And I'm going to run through this fairly quickly, as quickly as I can. I'm going to start by getting rid of the leading coefficient. Remember how we do that? Whatever it is, we divide everything by that thing. So we're going to divide everything across here by A. Okay, the whole left side divided by A, the whole right side divided by A. That's going to leave me with x squared plus b over ax plus c over a equals 0, because 0 divided by anything is still 0. Now I'm going to start completing the square, so I want the x parts on the left, x squared plus b over ax, and I'm going to have to subtract c over a to the right side. 0 minus c over a is just negative c over a. Remember to leave yourself a plus box. We don't know what's in the box yet, but we know how to find it. We come off to the side and we do b over 2 squared. Well, in this case, that's b over a divided by 2, and I'm going to make that a 2 over 1 squared. Well, you can't divide fractions by hand. Instead, what you have to do is you have to multiply the top one, which is b over a, times the reciprocal, or the flipped version of the bottom one. So it's going to be over, or b over a times 1/2, still squared. B times 1 is b. A times 2 is 2a, still squared. So that's going to be b squared over essentially 2a squared. And I'm just going to leave it this way for now. That's what's going to go in the box. B squared over 2a in parentheses squared. Should give myself a bigger, larger box there, shouldn't I have? All right. Okay, so this has been fun, hasn't it? Let's get back to our question. On the left side, we have permission now. Since this is a special case, we forced it to become a perfect square binomial, to say x plus b over a divided by 2. And when we did that a minute ago, b over a divided by 2, we got b over 2a. So it's going to be x plus b over 2a. All that in parentheses squared. I think on the right side, I'm going to take this 2a squared and go ahead and square it out. Let's do that. Okay, so 2 squared is 4a squared. I think that's what we're going to do there. Okay, and I'm going to switch the order of this thing. I'm going to put the b squared first over 4a squared. And I'm going to subtract c over a. Just want the c over a to the right and this part to the left. I think it's going to look nicer. All right, well, I kind of want to combine these two things together. In order to do that, I have to have like denominators. Right now, I don't have like denominators. What would I have to multiply this denominator on the right to have it be a like denominator? Well, I've got an a, and I need a 4a squared. So I'm going to have to multiply by a 4 and an a in the numerator and the denominator. That'll give me the 4, and the a times a will give me the a squared. Okay, so I've got x plus b over 2a squared equals b squared minus 4ac, because that's c times 4a, 4a times c, 4 times a times c, right? And all of that is going to be over 4a squared, because now we have like denominators. Now we have 4a squared here and 4a squared here, so we're going to put it all over 4a squared. All right, we're getting closer to the final answer. Next up, we got to take the square root of both sides. So on the right and the left, remember on the right it's positive or negative, and on the left it's going to cancel out that square root. So now on the left we have x plus b over 2a. And on the right, we have positive or negative, okay? On the top, square root of b squared minus 4ac. And on the bottom, since this is a monomial, we can go ahead and take the square root of 4 and the square root of a squared, which is 2a. All right, so my handwriting is getting kind of weak here, and I apologize for that, but we're almost done. We're getting there. We're going to subtract this b over 2a to the right side of the equal sign here, There's our equal sign. So we get negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, or just that part over 2a, all right? And what you should notice about these two fractions is they have the same denominator, so that we can combine them together and just put negative b plus or minus the square root of b squared minus 4ac all over 2a. What you'll notice is the variable is x, and what we now have is a formula that we can use for any quadratic, no matter what, and this is called the quadratic formula. This is the reason that when you plug in a, b, and c to this formula, after doing all of this crazy algebraic manipulation, this is why it works. Why the quadratic formula works is really just completing the square and making it into a formula that we can use every time. We will talk about the quadratic formula in videos to come soon. That is it for today. Hope that these level up questions weren't too bad for you. You could see a few of them in your future, and I will see you in class.